Well, it's interesting to read what the experts say. Here's an interview in Time magazine with one of the most widely quoted oil experts in all of Texas. They ask him, but haven't many of our bigger fields been drilled nearly dry? He responds saying there's still as much oil to be found in the U.S. as has ever been produced. Now let's assume he's right. What time is it? And the answer is it's 1 minute before 12. I've read several things this guy's written. I don't think he has any understanding of this very simple arithmetic. Well, in the crisis back in the 70s, ads such as this appeared. This is from the American Electric Power Company. It was a bit reassuring, sort of saying, now don't worry too much, because we're sitting on half of the world's known supply of coal, enough for over 500 years. Now, where did that 500-year figure come from? Well, it may have had its origin in this report to the Committee on Interior and Insular Affairs of the United States Senate, because in that report we find this sentence. At current levels of output and recovery, these American coal reserves can be expected to last more than 500 years. There is one of the most dangerous statements in the literature. It's dangerous because it's true. But it isn't the truth that makes it dangerous. The danger lies in the fact that people take the sentence apart. They just say coal will last 500 years. They forget the caveat with which the sentence started. And what were those opening words? At current levels. Now, what does that mean? It means if and only if we maintain zero growth of coal production in this country. So let's look at a few numbers. We go to the annual energy review published by the U.S. Department of Energy. They give this figure as the coal demonstrated reserve base, and it carries a footnote that says about half the demonstrated reserve base is estimated to be recoverable. You cannot recover and use 100% of the coal that's in the ground. So this number is half of this number, and we'll come back to those in just a moment. Now, the report also tells us that in the year 1971, we were mining coal in this country at this rate. 20 years later, 1991, we were mining at this rate. Put those numbers together, and the average growth rate of coal production in those 20 years was 2.86% per year. And so we have to ask, well, how long could a resource last if you had steady growth in the rate of consumption till the last bit of it was used? Well, I'll just show you that equation. For the expiration time, I'll tell you it takes first-year college calculus to derive that equation, so it can't be very difficult. You know, I have the feeling there must be dozens of people in this country who have had first-year college calculus. But let me suggest I think that equation's probably the best-kept scientific secret of the century. Now, let me show you why. If you use that equation to calculate the life expectancy of the reserve base, or of the 1/2 the reserve base that's estimated to be recoverable, for different steady rates of growth, you find if the growth rate is 0, the small estimate would go about 240 years. The large one would go close to 500 years. So that report to the Congress was correct. But look what we get when we plug in steady growth. Back in the 1970s, we had national goal of achieving 8% per year growth rate in coal production in the United States. If that could be achieved and continued, coal would last between 37 and 46 years. President Carter cut that goal roughly in half, hoping to reach 4% per year. If that could continue, coal would last between 59 and 75 years. Here's that 2.86 that we just saw, the average for a recent 20-year period. If that could continue, coal would run out between 72 and 94 years. That's within the life expectancy of children born today. The only way we're going to get anywhere near this widely quoted 500-year figure is to do simultaneously two highly improbable things. Number one, we've got to figure out how to use 100% of the coal that's in the ground. Number two, we've got to figure out how to have 500 years of zero growth of coal production. Now, these are simple facts. Just look at those numbers. I got a report recently from the coal fields of Kentucky, West Virginia, Virginia, these giant bituminous coal fields that supply a large fraction of the electricity in the eastern United States. They estimate that maybe they have another 30 years of coal mining before it will become uneconomical to mine there. And then what will we do when we want to switch on the lights? Let's now go back and note that in the 1970s there was great national concern about energy, but this concern disappeared in the 80s. Now, the concerns about energy in the 70s prompted experts, journalists, and scientists to assure the American people that there was no reason to be concerned. So let's go back now and look at some of those assurances from the 70s so we can see what to expect as the energy crisis returns. Here is the director of the Energy Division of the Oak Ridge National Laboratories. He's telling us how expensive it is to import oil, telling us we must have big increases in our use of coal. Under these conditions, he estimates America's coal reserves are so huge they could last a minimum of 300 years, probably a maximum of 1,000 years. Now, you've just seen the facts. Now you see what an expert tells us, and what can you conclude? There was a 3-hour television special on CBS on energy. The reporter said by the lowest estimate, we have enough coal for 200 years, but the highest enough for more than 1,000 years. You've just seen the facts. Now you see what a journalist tells us after careful study. And what can you conclude? In the Journal of Chemical Education, on the page for high school chemistry teachers, an article written by the scientific staff of the journal, we read that our proved coal reserves are enormous, and they give a figure. These could satisfy present U.S. energy needs for nearly 1,000 years. Let's do long division. You take the coal they say is there, divide by what was then the current rate of consumption, and you get 180 years. Now, they didn't say current rate of consumption. They said present U.S. energy needs. Coal today supplies about 1/5, around 20% of the energy that we use in this country. So if you'd like to calculate how long this quantity of coal could satisfy present U.S. energy needs, you have to multiply this denominator by 5. When you do that, you get 36 years. They said nearly 1,000 years. Newsweek magazine, in a cover story on energy, said at present rates of consumption, we have enough coal for 666.5 years. And the 0.5 means they think it'll run out in July instead of January. Now, if you round that off and say roughly 600 years, 600 is close enough to 500 to lie within the uncertainty of our knowledge of the size of the resource. So with that observation, that is a correct statement. At present rates, meaning zero growth, we have enough coal for around 600 years. The whole point of the story that this led into was that we have to have rapid growth in coal consumption in the United States. Now, it's obvious, isn't it? If you have the growth they're writing about, it won't last as long as they said it would last with zero growth. They never mentioned this. I wrote them a long letter, told them I thought this was a serious misrepresentation, to give the readers the feeling that we can have all the growth that they're writing about and still have coal around for 650 years. I got back a nice form letter. It had nothing to do with what I'd tried to explain to them. I gave this talk at a high school in Omaha, and after the talk, the high school physics teacher came to me, and he had a booklet. He said, have you seen this? I hadn't seen it. He said, look at this. We've got coal coming out of our ears. As reported by Forbes magazine, now that's a prominent business magazine, the United States has 437 billion tons of known coal reserves. That is a good figure. This is equivalent to a lot of BTUs, or it's enough energy to keep 100 million large electric generating plants going for the next 800 years or so. Now, the teacher said to me, how can that be true? That's one large electric generating plant for every 2 people in the United States. I said, of course it can't be true. It's absolute nonsense. Let's do long division to see how crazy it is. So you take the coal they say is there, divide by what was then the current rate of consumption, you find you couldn't keep that rate up for 800 years. We hardly have 500 large electric generating plants. They said it would be good for 100 million such plants. Time magazine tells us that beneath the pits heads of Appalachia and the Ohio Valley, and under the sprawling strip mines of the West, lie coal seams rich enough to meet the country's power needs for centuries, no matter how much energy consumption may grow. And so I give you a very fundamental observation. Don't believe any prediction of the life expectancy of a non-renewable resource until you have confirmed the prediction by repeating the calculation. As a corollary, we have to note that the more optimistic the prediction, the greater is the probability that it's based on faulty arithmetic or on no arithmetic at all. Again, from Time magazine, energy industries agree that to achieve some form of energy self-sufficiency, the U.S. must mine all the coal that it can. Now think about that for just a moment. Let me paraphrase it. The more rapidly we consume our resources, the more self-sufficient we'll be. Now, isn't that what it says? Well, David Brower called this the policy of strength through exhaustion. Now, here's an example of strength through exhaustion. Here is William Simon, energy advisor to the President of the United States. Simon says we should be trying to get as many holes drilled as possible to get the proven oil reserves. The more rapidly we can get the last of that oil up out of the ground and finish using it, the better off we'll be. Well, let's look at Dr. Hubbard's graph for oil production in the lower 48 states. There was a long period of approximately steady growth indicated by this straight line on the semi-logarithmic plot. But for quite a while now, production has fallen below the growth curve while our demand continued on up this growth curve until the 1970s. Now, it's obvious the difference between those two curves has to be made up with imports. And it was in early 1995 that the news told us that the year 1994 was the first year in our nation's history in which we had to import more oil than we were able to get out of our own ground. Well, maybe you're wondering, does it make any sense to imagine that we could have steady growth in the rate of consumption of a resource till the last bit of it was used and then the rate of consumption would plunge abruptly to zero? I say no, that does not make sense. You say, all right, why bother us then with the calculation of this expiration time? My answer is this: every segment of our society, our business leaders, government leaders, political leaders, the local level, state level, national level, everyone aspires to maintain a society in which all measures of material consumption continue to grow steadily, year after year after year, world without end. Now, since that's so central to everything we do, we ought to know where it would lead. On the other hand, we should recognize there is a better model. We turn again to the work of the late Dr. Hubbard. He has plotted the rate of consumption of resources that have already expired. He finds, yes, there is an early period of steady growth in the rate of consumption, but then the rate goes through a maximum and comes back down in a nice symmetric bell-shaped curve. And when he fitted this curve to the data on U.S. oil production back in the 1970s, he found that at that point we were right about there. We were 1/2 way through that enormous resource. Now, that's roughly what that Texas expert said in the quotation we saw earlier. Now let's see what it means. It means that from now on, domestic oil production can only go downhill, and it's downhill all the rest of the way. And it doesn't matter what they say inside the Beltway in Washington, D.C. Now, it means we could work hard and put some bumps on the downhill side of the curve. You'll see there are bumps on the uphill side. The debate is heating up over drilling in the Arctic Wildlife Refuge. I've seen the estimate that they might find 3.2 billion barrels of oil up there. 3.2 billion is the area of that little tiny square. That's less than 1 year's consumption in the United States. Now, let's look at the curve in this way. The area under the entire curve represents the entire resource of U.S. petroleum before any of it was used. Now, that area has been divided here into 3 parts. Unshaded on the left, that's the oil we've taken from the ground. We've used it, it's gone. This vertical shaded band, that's the oil we've drilled into. We've found it, we're pumping on it today. Shaded in green on the right is the undiscovered oil. We have very good ways now of estimating how much oil remains undiscovered. This is the undiscovered oil. This is the oil we're looking for in all those places where drilling is going on. This is the oil we've got to find if we're going to make it down the curve on schedule. Statements in the literature. It's dangerous because it's true. But it isn't the truth that makes it dangerous. The danger lies in the fact that people take the sentence apart. They just say coal will last 500 years. They forget the caveat with which the sentence started. And what were those opening words? At current levels. Now, what does that mean? It means if and only if we maintain zero growth of coal production in this country. So let's look at a few numbers. We go to the annual energy review published by the U.S. Department of Energy. They give this figure as the coal demonstrated reserve base, and it carries a footnote that says about half the demonstrated reserve base is estimated to be recoverable. You cannot recover and use 100% of the coal that's in the ground. So this, well, it's interesting to read what the experts say. Here's an interview in Time magazine with one of the most widely quoted oil experts in all of Texas. They ask him, but haven't many of our bigger fields been drilled nearly dry? He responds saying there's still as much oil to be found in the U.S. as has ever been produced. Now let's assume he's right. What time is it? And the answer is it's 500 years. Now, where did that 500-year figure come from? Well, it may have had its origin in this report to the Committee on Interior and Insular Affairs of the United States Senate, because in that report we find this sentence. At current levels of output and recovery, these American coal reserves can be expected to last more than 500 years. There is one of the most dangerous 1 minute before 12. I've read several things this guy's written. I don't think he has any understanding of this very simple arithmetic. Well, in the crisis back in the 70s, ads such as this appeared. This is from the American Electric Power Company. It was a bit reassuring, sort of saying, now don't worry too much, because we're sitting on half of the world's known supply of coal, enough for over